So here we are on page 66. We're continuing on by solving by elimination. We had some easy examples on page 65 where all we had to do was add the two equations as they were given together and one of the variables canceled nicely. Well, oftentimes they don't cancel nicely when you just add the two of them together. If you look at these two equations that were given, if we just add these two together, we're going to get 7x minus 3y equal 4. That's not going to help us at all. So you need to make it happen. You need to make the elimination happen. And you do that by multiplying one or sometimes both of the equations by a factor that will help you get something that cancels. So normally what we're looking at is we're looking at the variable that does not have a coefficient. So I see one right here. This y has a coefficient of -4. If in fact this were positive 4y, they could add together and cancel out. And we can make that happen by multiplying this top equation by 4. And it's legal to do that as long as I multiply by exactly the same factor all the way across the equation. I haven't changed the equality between the two terms on either side. So that becomes 16x plus 4y equals 20. And now if I write my second equation underneath it, I can add these two together and my positive 4y and negative 4y will cancel each other out. So that works pretty handily. I get 19x is equal to 19. Divide both sides, excuse me, of course, by 19, and you get x is equal to 1. So again, in looking for my solution, I'm pretty confident that x is equal to 1. I now need to find out what y is going to be. So we can go back to this top equation, or if you want to use the bottom one, you can do that one as well, and say 4 times 1 plus y equals 5, or 4 plus y equals 5, excuse me, and we are going to end up with y needing to equal 1. So I think that 1, 1 is my solution set of solving these two systems, but I'm going to do one final check, and I'm going to use this equation right here because I did not use him when I substituted in my x value to find the y. So if I make my shell here, whoops, wrong sign, that should be -4. And I think x is 1, and I think y is also 1. So I get 3 minus 4. Is that really equal to -1? Yes, it is. And now, if I were a betting person, I'd bet money that this actually is the answer to my solution. So the only thing that we did a little bit differently, the extra step we had to do in example 2 on the other page, was actually decide what to multiply one of our equations by to get one of these two variables to cancel out. So on example B, I am again looking at this x on top that does not have a coefficient at all. The guy that we're going to combine him with is a positive 5x, so I need to multiply through by -5. When I do that, I get -5x minus 20y equals, what is that, -70? Yeah, -70. So if I write my original second equation right underneath it, and I go add them together, those cancel nicely, and I end up with -17y equaling -68. Divide both sides by -17. And I end up with y is equal to +4. So in order to find, I'll go ahead and write what I think my solution is going to be. And I need to find the x that goes with this +4. So I'm going to pick the easy equation to start with here. x plus 4 times 4 equals 14. X plus 16 equals 14. So x has to equal -2. And then I will leave the check to you. You will take this second equation, you'll plug in -2 for x and 4 for y, do the arithmetic, and see if this left-hand side really does simplify to +2. That will be your final step on the check. So let's look, I'll do one more of these in this video to get you guys started. On C, it's not obvious that we can just multiply one of these equations by anything and have something cancel out. So I don't have a variable without a coefficient. So I'm really going to need to find a common multiple, something that I can multiply both equations by and get it to cancel out. Now, it's important that I say right here that you don't have to multiply both equations by the same number. You just have to multiply each term in the equation by the same number. So if I'm looking at, I've got a negative and a positive, so maybe I'll work with the y's. And I'm trying to think, well, a common multiple between 3 and 2 is 6. So if I could get a plus 6y and a minus 6y, those would cancel nicely. So in order to get a plus 6y, I'm going to multiply this entire equation by 2. And in order to get a minus 6y down here, I'm going to multiply the second equation by +3. And once I do that, I've got 8x plus 6y equals -38, and 9x minus 6y equals -30. And again, even though these numbers are bigger and they're not what we started with, we can add our equations together. Those guys, I don't know why I said x there, that's a y. Those guys will cancel nicely, and we end up with 17x equals -68. Divide, and we get x equals -4. So I'll write my answer, that part of it up here, and to find the y, we need to go back to one of these two original equations. Again, it really doesn't matter which one you pick. To start with, you're just solving for y, so that's -16 plus 3y equals -19. Add 16 to both sides, 3y equals -3. Divide, and you get y is equal to -1. You would have gotten the same value for y if you had picked the second equation to start with. So I might think I'm finished, but I'm not. Your third step should be your check. I used this equation to find y, so I'm going to use this equation for the check. 3x minus 2y equals -10. So 3 times -4 minus 2 times -1. Is that really equal to -10? That's a question mark. So let's see. -12 plus 2. Yep. So pretty confident about our answer. And I will leave you guys to do this one on your own. It sets up much like C. You've got to figure out which of these variables you're going to get rid of. And there's not just one way to do it. Obviously, you can get rid of the x by multiplying by a multiple of 3 and 4, or you can multiply by a multiple of 2 and 3. One thing I will tell you is that since all of these coefficients are positive, one of your equations is going to have to be multiplied by a negative factor and one by a positive factor. So see what you can do with that one, and we'll come back and talk about it in class. Thanks for watching.